Hi, everybody. Let's do another example with solving systems of equations. All right, so the second example I want to do is going to be 5x minus 3y equals 4 and negative 3x plus 2y equals 1. Now, again, all three strategies are good to do. So the first one I'm going to walk through with you is going to be the graphing one. And remember here, you're looking for the intersection. So graphing is a good way to start to get an idea of what you think your answer is going to be or to check as well. But graphing is not perfect. If you do it by hand, you could be a little bit off. Or if the intersection is not at a perfect integer answer, it's very hard to sometimes figure out. So it's a good start, but usually we do something algebraic as well to solve. But I think it's good to show you what it looks like in Desmos first. Okay. All right, so I'm just going to type in these two equations. I'm just using Desmos as my graphing utility here, but you can use any graphing calculator. I particularly love Desmos because it is free and it is super intuitive and easy to use, and they even have an app for your phone. So it just makes it really nice. So here are my two equations. Let me make sure I didn't type anything incorrectly. And so far, if I look at it, I don't really see any intersections, but it does look like they're getting closer together. So maybe we should zoom out a little bit. And it does look like somewhere up here that we do have an intersection. I'm going to try to zoom in on that spot. All right, so it does look like we're intersecting here, potentially at 1117. So that's what I'm going to guess my solution is. It does look like those graphs cross at exactly 1117, which is nice. So we should see that exactly for our answer. But again, graphing is a good way to start or check, but you really want to go through the algebra as well to verify that that answer is accurate, especially if you're trying to visually just find a point. Again, what if the answer was 11.1 comma 17.2 or something, right? So it could be a little bit off. So let's get out my paper. And let's see. And let's do the algebra as well. So again, our guess here was 1117 is what it looks like, but we're going to go ahead and do our algebra. Now I'm going to do both methods just so you can see it one more time. But really, you don't have to solve using both methods every time, right? You would use the one that's easiest. Sometimes one is easier than the other. In this case, I would probably use elimination because my variables are already kind of lined up in order. Substitution is really nice when one of your variables is already solved, right? If something is already in y equals form, then jump right in with substitution. It's already solved for you. So here, I have to choose one of these equations to solve first. I think I'm going to choose this one here to solve. I know the numbers look a little bit nicer than the 5 and the 4. I'm going to solve, let's solve for x this time. So I'm going to bring that 2y to the other side. And then I'm going to divide everything by -3. And don't forget, both things get divided. So this becomes 2/3 y, those negatives will cancel, minus 1/3. And your next step in substitution was to go back to the other equation then and to plug this in. So if I use this equation already, then I'm going to use the other equation to plug in. And don't forget, you have all the steps for this in the first video. So if you need to go back to those steps, rewrite them again on your paper here and follow that same process that we did. So I'm going to take my x and I'm going to substitute in for the x here. And I'm going to go ahead and distribute that 5. Now it's 5 over 1, so I multiply straight across. I get 10/3 y minus 5/3 minus 3y equals 4. And again, here, I particularly don't really like fractions that much to work with for equations, so I'm going to cancel it out. My only denominators are 3's, So what you do to cancel fractions is you multiply by a common denominator. Here I can just use 3. And just make sure you multiply both sides. You do have to keep the equation balanced. So this 3 is going to get distributed. Now, if you can do some of this in your head, that's okay. Just make sure you don't make any little mistakes. So I'm left with 10y minus 5 minus 9y equals 12. And then 10 minus 9 is obviously 1. So 1 minus 5 equals 12. Add that 5 to both sides, and I get 17, which is actually what I was thinking with my graph. And then your last step is to take this value and plug it back in. And you can use either equation. So I'm going to go back. We'll just use this one right here. So I have 5x minus 3 times 17 equals 4. 3 times 17 is 51. I'm going to add that 51 to both sides. And divide by 5. And I get that x is equal to 11. So I do have that solution that I was thinking of from my graph, although it's a little hard to find. I had to kind of zoom in and out a few times. But 11, 17, again, your x and then your y value would be the solution. And this solution works in both equations. So it's where they intersect graphically, that's the visual. And it's that solution that works in both. I'm not going to do the check, but you can try it at home. So take your answer, plug it into both equations, and make sure you get true statements. If you get a true statement in both, then you know you have the right answer. Let's go ahead and try this one with elimination as well. So I have my two equations, and remember with elimination, you like to line them up so that your variables are on top of each other. So your x's are on top and then your y's are on top, which is important. So if you need to do rearranging, you can. Excuse me, here, I don't see an easy way just to cancel something, right? Like I can't just, I mean, I guess I could multiply this by like 3/5 or something like that to get the x's to cancel, but I really don't want to multiply by fractions. So I'm going to use whole numbers here. So I think what I'm going to do is I'm going to multiply my top one by 2 and my bottom one by 3. I'm choosing this because that will get my y's to cancel. -3 times 2 is 6, and 2 times 3 is +6, so I can cancel my y's. It doesn't matter which variable you cancel to start, so just pick whatever you think is easiest to do. So I have 10x minus 6y equals 8. And then I have -9x plus 6y equals 3. And now we add those together. So you're actually adding those two equations, and you'll see that one variable does cancel. 10 minus 9 is 1, so that is just x equals 11. Here, I don't have any other solving really for this piece. I just have the answer for x equals 11, but I do have to plug it back in to get the y value. So try to go back to your original problems. I recommend not going back to the middle steps, because if you made a mistake, it just compounds the error even more. So go back to the original. I'm going to use the first one here. I'm going to plug in 11 for x. Subtract that 55 to both sides. I get -51. And then when I divide, I get 17. So again, I have that same answer here, 11, 17.